Hey guys, hope you had an easier time with this project than I did. Here is my video tutorial for alignment practice 2. Let me go ahead and share my screen with you. All right, so for alignment practice 2, we were supposed to do pairwise alignments for test 1 and test 2 using BLAST, FASTA, and PRSS. So first thing that we did is I went to the link for test 1 and test 2, which we've got right here. So these are the two. Went ahead and copied test 1. Then we went to the BLAST local alignment search tool. We were told to go down to the global align, which is what we did. So you copy and paste test 1 here and test 2 at the bottom. And then we did a BLAST search. I'm not going to subject you to that. I'm just going to show you what the end result was. So the end result of this particular global alignment BLAST search between test 1 and test 2 showed us a score of -40, 17%. Graphic summary, we did have some hits here on the subject sequences, and I went ahead and posted the alignments. We don't have particularly good coverage, but we have decent enough hits. It's not like they're completely dissimilar to each other. Then we were supposed to do it in the FASTA algorithm, which I did up here. Apologize for right here. So to do that, we typed in the test 1 sequence for this and limited the query to the structure unit pro KB PDB database. And we had to see what scores we received for the alignment between protein test 1 and test 2. Now, if you remember, test 2 was the GTP cyclohydrolase 1, which we did find on here, if this would allow me to do it. All right, so under FASTA, it should be the 7th one down. And see, you see GTP cyclohydrolase from our Thermus thermophilus. And we got a score of 30.7, which I copied and pasted into a Word document to submit. Now it asks if we found it using BLAST. So I attempted to, and my first attempt using just the PDP, your BLAST P, all the regular searches didn't show up with anything, but I attempted it again using changing the expected threshold from 0.05 to 0.8 as she showed us in one of the tutorials. And you see it right here. It's the last one here. Got a cover of 39, total score of 31.2. Its e-value is 0.69, so it's not a real good match. But we knew that from some of the other projects. So since we were able to find it much easier using FASTA, I'm going to assume that one of the things that we specifically, my assumption was that FASTA has a less stringent database. I'm not sure if that's the right answer, but that's what I decided to go with. So on the third one, we were supposed to run the PRSS test to check whether there's any statistically significant similarity between the two sequences. So I went to the PRSS website, typed in, copied test 1 into the first box, test 2 into the second box, and then I hit shuffle sequence. And this is what we got. So I was looking down here, and per our notes, looks like it's checking similarity as opposed to identity. It's not telling us what these proteins are, but it is showing us how similar they are and where the bases match up, either an exact match like here with the 2 dots here, or with a what I call a good enough match, say here between the H and the R with these little 1 dots. So I think that that's what this program specifically does. It checks similarity as opposed to identity. So the last thing we were supposed to check is to find the paper, PMID 107-37935, which, you know, you can just type that directly into Google and it'll take you to the PubMed. And that is this particular one, Sequence and Structural Features of the T-Fold, an Original Tunneling Building Unit. So I went to the Wiley full text article, which I've got actually up over here on the Wiley online library, got to it through the UF portal. This is specifically talking about T-fold proteins, and they are extremely common. As you read through here and you see that there's multiple enzymes and proteins that use that particular T-fold, including, if I can find it down here, it was specifically mentioned cyclohydrolase, which was test sequence 2. See if we can find that. I'm going to do a quick Control F. There we go. GTP cyclohydrolase, which its first domain is an all alpha domain. Second domain is a T-fold, which is what this paper is talking about. And if you go and look at the cited by papers in PubMed, you'll see that there are a lot of different papers about proteins with enzymatic activity, including GTP cyclohydrolase 1. And there's at least 4 of them in here that deal with that specifically deal with reductase activity, which is what protein in the test 1 sequence protein codes for. So I said that this motif being common in enzymatic activity makes it absolutely biologically relevant. I know I went through that pretty fast. I hope that that helped. I look forward to seeing you guys look forward to seeing y'all's tutorials. I think I could learn a lot more from that, because right now I'm not entirely certain if I know anything at all. Y'all have a good day.